Hello friends, and welcome to the tutorial series on LABVIEW for engineers. Myself Siddharth Bhardwaj, currently a senior research fellow in the Department of Mechanical Engineering and associated with Ergonomics Research Division, Aligarh Muslim University. I have over 5 years of experience working with LABVIEW for research projects. These tutorials are intended to help learn the concepts of programming, data acquisition, and signal processing using LABVIEW. The objectives of this tutorial series will be to get you familiar with graphical programming, learn controlling the data flow in LABVIEW using structures and tunnels, start working with different data types in LABVIEW, learning how to read and write data in and out of the program using file input-output functions, creating and using sub-VIs, signal measurement and their analysis, and instrument control using third-party hardware like Arduino. Before coming to programming itself, let's talk about features and important points special to LABVIEW program. LABVIEW stands for Laboratory Virtual Instrument Engineering Workbench. As the name applies, LABVIEW is most often used for measurement, test, and control applications. And in sense, the LABVIEW programs are called VIs, or the virtual instrument. But there are two unique aspects that make LABVIEW different from other languages. One is the graphical programming interface, and second is the data flow programming. Regular textual programming languages are based on the concepts of control flow, which is geared towards making things happen one step at a time with explicit ordering. But in LABVIEW, the concept of data flow is applied. All it cares that each node have all its input available before execution. In this way, LABVIEW is inherently parallel, and so the application can scale automatically to take the advantage of multi-core CPUs. And this is all with no extra programming effort. Furthermore, LABVIEW has a strong library support for various data acquisition systems to generate and analyze analog and digital signals. This makes programming with LABVIEW easier, whether you are working with image processing, biomedical signals, or human response to sound and vibration. You have toolkits for them, which makes the programming a lot more easier than other programming languages. The course will cover tutorials on these aspects of LABVIEW. I hope you will enjoy the course and get benefit from it. Thank you, and see you in the following series of LABVIEW for engineers.